Hello viewers, welcome to Elimu TV where I watch and learn. I'm your tutor Alex Musawa and I'll be taking you through Chemistry Form 1, our lesson number 29. Our topic is Simple Classification of Substances and our subtopic is Kinetic Theory of Matter. And what are the objectives of this lesson? To describe what is kinetic theory of matter. And so, it said that matter is made up of particles which are in continuous random motion. That is kinetic theory of matter. Okay, as you can see from the diagram, we have solid, liquid, and gases. According to kinetic theory, in the solid state, the particles are closely packed together and can only vibrate within fixed positions. As you can see, the particles of a solid are closely packed together. They do not move from one point to another because there are forces that hold them in these positions. Now, when we heat a solid, what happens? When the solid is heated, the kinetic energy of the particles increases and they begin to vibrate more vigorously at a certain temperature which is fixed for particular substance, and the forces holding the particles are weakened, and then the solid turns into a liquid. The temperature at which the solid turns into a liquid, which is constant, is called the melting point. It's called the melting point. In the liquid state, the particles are not as close together as they are in the solid state. They can move from one position to another within the liquid. This explains why a liquid has no definite shape. As you can see, liquids have no definite shape. They assume and take the shape of the container. However, a liquid has a definite volume. The volume of a liquid is measured in ml. The particles exert some attraction on one another, and these forces of attraction make them to stay together. Now, when we heat a liquid, the particles move more rapidly as the forces of attraction are further weakened. As you can see, the liquid turns to gas when we heat. The weakening continues until the particles gain enough energy to overcome the forces between them. As you can see, the forces are being overcome. And the point the liquid boils, the constant temperature at which the pure liquid boils is called the boiling point, and it is fixed for a particular substance. Let's say water has a specific type of boiling point, and the boiling point of water is 100 or 99. It depends on the atmospheric pressure, while the boiling point of naphthalene is 79 degrees and of ethanol is about 78 degrees. In the gaseous state, the particles are far apart and free to move randomly in all directions. That is why a gas does not have a definite shape or volume but occupies the whole space within a container. When a gas is cooled, the particles lose kinetic energy and slow down. As they slow down, they easily attract their neighboring particles and move close to form a liquid. The process is called condensation. Next, we're going to look on the effects of impurities on melting and the boiling point of substances. What happens when you add an impurity to a substance? Definitely, an impurity is going to change the melting point and the boiling point of a substance. Let's say, for example, the melting point of pure naphthalene is about 80.2 degrees Celsius. If we add camphor, which is another substance and is an impurity, the naphthalene melts over a temperature range that is lower than the melting point of pure naphthalene. Therefore, impure naphthalene does not have a sharp melting point. So, impurities lower the melting point of substances. And what are the effects of adding impurities on the boiling point of impurities? What are the effects of impurities on the boiling point of water? Impurities raise the boiling point of water. That means to say that a liquid now boils at a higher temperature. Let's say you add impurities on water. water boils at about 99 degrees to 100 degrees. But when you add some impurities, its boiling point is going to increase, and it's going to boil at a higher temperature. And that is the end of our topic. So I have questions for you. Number one, clearing ice from roads. What effects and what are the applications of adding impurities in a substance? Number one, in places where there is ice, we have to look for a way in which we can make the ice melt. So how do we do? Clearing ice from roads, let's say in regions where there is a lot of snow, by spreading common salt on the ice, and this makes the ice to melt faster. It's also used in extraction of metals from molten compounds. Impurities lower the melting point, and therefore it's going to be cheaper. And that is the end of our lesson. And I have an activity for you. Number one, what effect do impurities have on the boiling point? Number two, at what temperature does pure and impure water boil? Our reference book is KLB Book 1, 5th edition, 2019. For more information, contact us on our phone number, YouTube, Elimu TV, Facebook, Elimu TV, and finally on Twitter at Elimu TV _KE. Thank you for watching Elimu TV. Stay tuned.